Today we're going to be taking a look at an integration technique called u-Substitution, and we use it extensively. We are required to use it quite a bit when we're finding antiderivatives. So I like to equate this to the chain rule. It's not a chain rule, but it takes into account the chain rule when we are finding derivatives. So it's kind of like the equivalent of the chain rule. All right. So by the way, we could call this any kind of substitution. It's just typically called u-Substitution or just u-sub, but we could easily call it some other kind of substitution. The u is not magical, of course. Alrighty, let's take a look at this example. So if we had, let me grab a piece of scratch paper here. If I had the integral of just x to the 8th dx, that would not be a problem for us. We would just use the power rule for integrals. So we would raise the power by 1, we would divide by our new power, add a c, and we would be done. Easy peasy power rule. So what if it's not an x? What if it's something like this, 2x minus 1 to the 8th? Well, I like to think of this as it's going to behave like that one. It's going to behave like it, but it's not going to be exactly the same. Here's why. If we treated this, if we did treat this exactly like just a regular x, then we would say that this is 2x minus 1 to the 9 over 9, right? That's what we would say. Which means that if we took the derivative of this, we should get that, right? So let's do that. Let's take the derivative of this expression. The plus c, I could put the plus c there, but when we take the derivative of it, it's just going to be a 0, right? So let's do it. This is a chain rule. So 9 times the front would be 1. 2x minus 1 to the 8th, right? Times the derivative of the inside, 2. Is that derivative the same thing that we started with? No, it is not, because it has this extra 2, right? So u-Substitution will help us take care of that 2 there, all right? Okay, let's go ahead and get started. So when I see an integral with something being raised to a power that is not a plain x, I think to myself, that is going to be my u. What is being raised to the power is going to be my u. So u will equal 2x minus 1. Now we're going to take the derivative because I'm doing a u-Substitution, but I still have x's. When you do a u-Substitution, we need to change the dx to a du. Okay, so here it comes. So I'm going to take the derivative. I'm going to take the derivative of both sides with respect to x. All right. So this would be du dx. Do you agree? Du dx. Derivative with respect to x. So du dx. Only I'm not going to write the dx under here. I'm going to multiply it to the other side, and I'm going to write it over on the right-hand side. The derivative of this with respect to x is 2, and now here comes the dx that I'm multiplying to the other side, a differential of x. So there's that 2 that we were needing, right? So here's what I'm going to do. I'm going to put a 2 right here because I want 2 dx. And here is 2 dx. Now I'm substituting. So I'm going to substitute in place of the 2 dx my du. So that's going to be my du. But I can't just write a 2 there, because if I write a 2 here, I have changed the value, true? So when I write a 2 there, I'm going to, on the outside, multiply by 1/2. This way it keeps everything even, keeps everything the same. So my integral has become 1/2 integral u to the 8 du. And now we can use the power rule that we wanted to use from the get-go. So 1/2, raise your power by 1, divide by your new power, plus c. So that's going to be 1/18. And now I can go back to what u was equal to. U was equal to 2x plus 1. And there's my answer. If we take the derivative of this, we do get that. Okay? All right, one more thing before I leave this problem. This spot right here is a safe stop spot if you told me what u was equal to. If you say what u is, and I said what u was right there. So if this is an FRQ, then you could stop right there because you've said what u is. This, though, would be the multiple choice answer. Alrighty? Okay, so let's do another one. So I'm asking myself, when I first look at this, I'm saying, okay, what is being raised to the power? 6x minus 1 is being raised to the power, so that's going to be my u. So u is 6x minus 1. So what is du? The derivative of u is the derivative of 6x minus 1, 6 dx. So I need to put a 6 right here and a 1/6 out there. So here is my du. So my integrand now, my integral has become u to the 2/3 du. And now we use the power rule. Raise your power by 1, divide by your new power, plus c. That would be a safe stop spot as long as you tell me what u is equal to. And as a multiple choice answer, this would be, let's see, 3 goes into 6 twice, so 1/10, 6x minus 1 to the 5/3 plus c. Multiple choice answer. Alrighty, let's look at number 3 here. In number 3, what is being raised to the power? Well, I have two things being raised to a power. I have x to the second power, and I have this to the second power. So when you're trying to decide what to let u equal, let it be the more complicated thing. So this is going to be my u. And as you practice these over and over and over again, it will be more obvious what to let u equal. But this is going to be my u. So u is 4x cubed minus 3. du is 12x squared dx. All right. The x squared dx. Do we have the x squared dx? Yes, we do. We have the x squared dx. Do we have the 12? No, we do not. So I'm going to multiply by the 12. And then on the outside, multiply by 1/12. So my integral has become 1/12 integral of, all right, this right here, all of that is my du. So I have 1/u squared du. Okay? So now we integrate. I have to bring the u to the top and give it a negative power, just like we did already. So u to the negative 2 du. And now we add 1 to the power. Divide by our new power. It's going to make this negative. So that's going to be a negative 1/12 times u to the first, so 4x cubed minus 3 plus c. All right. Before I go any further, I want to I want to make note of something. Ignoring that 1/12 and only looking at the integral of 1 over u squared, we got negative 1 over u. That is a good thing to memorize. The integral, because it pops up a lot. 1 over u squared in an integral is negative 1 over u. Okay? Good thing to memorize because it pops up a lot and it saves you from doing 2 of the steps. Alrighty? Okay, number 4. I'm going to let u be the thing inside the parentheses being raised to the power, so u is x to the 5th plus 6. du is 5x to the 4th dx. Okay, what do we have here? Well, there's my dx. Here's my x to the 4th. I need a 5 and I have a 3. Well, this 3 is any number that's there already is never a problem. We can always take a number outside of the integral. So that's not a problem. So I want to take the 3 outside. By the way, you can never take an x outside the integral. All right? No x's. No x's can be outside of the integral. Only a number. Okay? Alrighty. I want the 5 in there though. So I'm going to take the 3 out as a 3 and I'm going to multiply a 5 in. But that's changing it, so I'm going to multiply by 1/5 on the outside. So my integral is 3 over 5 integral u to the 7 du. And now power rule. Raise your power by 1, divide by your new power. As a multiple choice answer, 3 over 40, x to the 5th plus 6 to the 8th power plus c. Okay, so they will just go back to x's at the end for multiple choice answers. Okay, number 5. I'm going to let u be what's being raised to the power. So u is 2x squared minus 1. du is 4x dx. I have the x dx. I need the 4, so I multiply by 1/4. 1/4. 1 over the cubed root of u du, right? So I'm going to bring that u to the top, give it a negative power, and use the power rule. Add 1 to the power, divide by your new power, plus c. Multiple choice answer, 3/8, 2x squared minus 1 to the 2/3 plus c. Okay? Around this time, students usually say, Miss Murray, what if that x wasn't there? What if that x wasn't there? You cannot multiply by an x in here and take an x out here. It does not work that way. You cannot do it. You can only put a number. You can only multiply by a number here. No x's. So this x here, I like to call it a little gift from Santa Claus. It's a little gift from Santa. Okay? It has to be there. If it wasn't there, we couldn't do this problem with u-substitution. We would have to use a different technique. So in number 4, what was the gift from Santa Claus? The gift from Santa Claus was this guy right here, that x to the 4th. Little gift from Santa. Just what we needed. Here the gift was the x squared. Okay? So, let's take a look at number 6. In number 6, okay, I'm going to let u be what's being raised to the power. So u is x squared plus 4x minus 3. du is 2x plus 4. Now here we have two pieces, so I'm going to use parentheses around that and make it dx there. Okay, keep my distribution right. Okay, we have that. Well, we were given this, and we have that. If I factor a 2 out of this, then I have the x plus 2. Then I have the x plus 2 here, dx. I need to multiply by 2 though, so I'm going to multiply by 2 on top, which means I need to multiply by a half on the outside to keep everything equal, everything legitimate. Okay, so my new integral is 1/2 integral 1 over u squared du. And here's the one, again, it pops up a lot, 1 over u squared. So we could do it the long way and move it to the top, give it a negative power, use the power rule, or we can have this memorized. The integral of 1 over u squared is negative 1 over u. So as a multiple choice answer, they would go back to x's, they would send that back to the bottom, like that. And they would take that negative out in front of the whole thing. Alrighty, let's take a look at some trig functions. So, this is not a plain cosine of x, it's a cosine of 4x. So I'm going to let u be the 4x. So u is 4x. du is 4 dx. 4 dx. So I'm going to multiply a 4 with my dx and multiply by 1/4 out in front. So this is the same as 1/4 integral cosine of u du. And we know what the integral of cosine of u du is. That would be positive sine of u plus c. And then going back to the x's, we get that. So let's recap this. We found out that the integral of cosine of 4x dx is 1/4 sine of 4x, right? So if you know what this is going to do, you can do it without going through, a lot. If you notice the pattern, let's put it that way, notice the pattern here. Alrighty. This integral, I am going to let u be 10x. U is 10x. So du is 10 dx. So I need to multiply in here a 10 on the outside by 1/10, and now I have a du in the back. So my integral has become 1/10. I'm going to swap these. I like to see secant first. It doesn't matter, but I like to see secant first. Secant u, tangent u, du. Right? And I know a function whose derivative is secant u tangent u. I know a function whose derivative is that, and it is secant u. So this is just 1/10 secant of u, and u is 10x. So if you can get there immediately using our pattern, that might be a nice thing, right? Might be a good thing to do. So that is doing a u sub where you let u be the argument. U is the argument. Let's now do a u sub where we're not going to let u be the argument. We're going to let u be an actual trig function. So again, you guys, I'm going to let u be what is being raised to the power. And what is being raised to the power here? Sine of x is being raised to the power. So I'm going to let u be sine of x. What is du? Well, what's the derivative of sine x? The derivative of sine x is positive cosine x, dx, which is sitting right here. There's the gift from Santa, right there. It's exact. So that is my du, and this is u cubed, right? So I have just the integral, I don't know why I'm rewriting this, but just the integral of u cubed du, which is 1/4 u to the 4th plus c. 1/4 sine to the 4th x plus c. If you take the derivative of this, you will get that. Chain rule. Okay? Over here, what should we let u be? What should we let u be? I want to let u be a function whose derivative is the Christmas present. I'm going to let u be tangent x. I'm going to let u be tangent x because what is the derivative of tangent x? Secant squared x, right? Which is sitting there, the Christmas present from Santa. Yes? So this is my du, this is u squared, so my integral is u squared du. Little power rule here, 1/3 u cubed plus c, written as a multiple choice answer, 1/3 tangent cubed x plus c. If you take the derivative of this, you will get the integrand. Okay. Now, what if we have boundaries on our integrals? Remember that we are doing u-substitution. So we're changing every x to a u. Well, in this problem, these boundaries right now, these are x's. These are x's, right? This is from x equals 0 to x equals 1. So when you do a u-sub, you're going to have to change your boundaries to make them u boundaries. And that's the only thing additional to this right here. Okay, I'm going to start doing a u-sub. So I'm going to let u be what's inside of the power, right? So u is 1 minus x squared. du is negative 2x dx. I have the x dx. I need the negative 2, so I'm going to multiply in a negative 2, and on the outside negative 1/2. So my integral, just the integral part, has become negative 1/2 integral square root of u, which I'm going to write as u to the 1/2 du. This negative 2x dx, I could put those all together to make it my du. Those are equal, right? Okay. Now for the boundaries. The x boundary, the top boundary was a 1 for x. I want to make it a u. So all I have to do is go to my x over here and put 1 in for x. If I put 1 in for x, my new u, my new upper boundary is going to be 0. For my lower boundary, I'm going to put 0 in for x. I'm going to put 0 in for x now. And my new lower boundary is 1. So sometimes this happens to where once you change to u's, your larger boundary is now on the bottom. And we don't want it on the bottom. I'm going to flip those, put the 1 on top, and multiply the outside by a negative 1. So now it's going to be a positive 1/2 on the outside. Everything else stays the same. So this is 1/2 definite integral. I'm going to use brackets on that. Power rule, so add 1 to the power, divide by your new power, and we're going from 0 to 1. Now, in the other problems that we have done, my last step was to go back to x's, because most of these will be multiple choice questions, all right? So that's what they're going to do for the multiple choice question. However, down here with the definite integrals, we changed to u boundaries, didn't we? And we have a u there. If we go back to x's now, we cannot keep our u boundaries. We would have to revert to our x boundaries, and since we've switched those, it's going to be a little complicated. So don't go back to x's. If you have boundaries, do not go back to x's. If you took the time to change your to u boundaries, then don't go back to x's. You stick with your u's. First I'm going to multiply these two together. 1/2 times 2/3 is 1/3. And now 1 goes in for u, minus 0 goes in for u. 1 to a power is 1, 0 to a power is 0, so this is just 1/3. I want to show you guys something on the calculator, just to refresh or remind ourselves that we can check our answers with our calculator. We can do this with a calculator. Math 9 for integral. We started with 0 to 1 of x square root 1 minus x squared dx. And did we get a third? Yes, we did. We got a third. We have to be able to interpret that as a third. This is the error, because there's no little man taking an integral in there. This once the calculator reached its programmed tolerance level, it stopped going, because they're taking this, it's a numerical derivative, so this is not the exact answer. Okay, but remember that these answers will always be correct to the third place after the decimal point, always. All right, let's do another one here. Okay, I'm going to let u be the x squared plus 4. du is 2x dx. The x dx is there, the gift from Santa, but I need a 2, so I'm going to multiply by 1/2. And my integral is 1/2 the integral 1 over square root of u du. But what is my new upper boundary? It was the square root of 5, but that was an x, right? If I put square root of 5 in for x here, I'm squaring it, so I get a 5 plus 4, that's going to be a 9. So my u boundary is a 9. For my new lower boundary, I'm going to put 0 in for that x, and my u boundary will be a 4. Okay. I'm going to bring the u to the top, give it a negative power, and use the power rule. Raise your power by 1, divide by your new power, multiply our numbers together, and that's just a 1. So we get 9 to the 1/2 minus 4 to the 1/2. 3 minus 2 is 1. Okay? Next one, we're going to let u be the x cubed plus 1 du is 3x squared dx. I must have a gift from Santa of an x squared, and I do. I have a gift from Santa of that x squared. He also left a 4, which we really don't want. I'm just going to pop it outside of the integral. and in its place I'm going to put a 3. So I'm going to take the 4 out, I don't want it, and I'm going to put a 3 in. So I also need to multiply by 1/3. So my new coefficient out in front will be a 4 over 3 integral. There's my du, and so it's just u to the 1/2 du. Okay, what is my new upper boundary? This was the x, so I'm putting 2 in for this x. 2 cubed is 8, plus 1 is 9. My new upper boundary is 9. My new lower boundary, I'm putting a 2 in for x. My new lower boundary is 1. I'm sorry, my new lower boundary is 2. I was just thinking to myself, I should have made that a 0 in the notes, but oh well, I didn't. Okay, alrighty, so now, power rule, raise your power by 1, divide by your new power, multiply these two fractions together, we get 8 over 9 times 9 to the 3/2. 9 to the 3/2, oh, I'll write it like this, 9 to the 3/2 minus 2 to the 3/2. By the way, this would be a safe stop spot, of course. It's all numbers. Okay? That would be a safe stop spot, all numbers. This, kids want for this to be a safe stop spot, but it is not. That is not safe stop. Okay? You cannot stop until you have plugged everything in. Okay? Alrighty. As a multiple choice answer, they would clean up this 9 to the 3/2. The square root of 9 is 3, and 3 cubed is 27, so they would change that to a 27. Everything else they would leave the same. So as a multiple choice answer, it would probably look like this. Okay? Alrighty, one more. How's my time doing? Pretty good. Okay. One more here. Alright, I'm going to let u be what's being raised to the power. So u is cosine x. The derivative of cosine x is negative sine x. My gift from Santa must be a sine x. And I do have an extra sine x. Okay, all I need is a minus, so I'm going to put a minus inside and a minus outside, because two negatives multiplied together will be back to a positive. So my integral is now negative integral u to the 1/2 du, right? What's my new upper boundary? My new upper boundary, I'm putting pi over 2 in for x. Cosine of pi over 2 is 0. My new lower boundary, I'm putting 0 in for x. Cosine of 0 is 1. So once again, we ended up with an integral with reversed boundaries, so I am going to put my lower boundary on top, on the bottom, and my higher boundary on top, multiply by a negative, so it's going to send it back to being a positive. And now we're just going to use the power rule. So u to the 3/2 times 2/3 from 0 to 1. Okay. This 2/3 I like to think of as being outside of the brackets. So that's 2/3 times 1 to the 3/2 minus 0 to the 3/2. So this is just 2/3. Let's see, since we have another moment here on my time, let's see what the calculator does with this. See how close, how much of an error it has. So math 9, 0 to pi over 2 sine of x times the square root of cosine of x. So this one had a little bit larger of an error, I think, than the other one did, which I kind of expected, being trig functions in here. But you can still see the 2/3, right? And remember that's always going to be accurate to the thousandths place. Alrighty. That is it for u-sub. It's a super, super important technique. We will be using u-sub the entire rest of the year. Okay? So, super important to learn this well.